Not long ago, NVIDIA was a company most people associated with gamers. If you built a powerful PC or wanted smoother graphics, you probably knew its green logo. Today, that same company has become one of the most valuable businesses in history, surpassing industrial giants, oil empires, and many of the world's biggest technology firms. That transformation seems almost impossible, until you realize the world has been looking at NVIDIA through the wrong lens. Because NVIDIA doesn't really sell graphics cards anymore. Its most valuable product isn't a piece of hardware sitting inside a computer. It's the foundation upon which the modern AI economy is being built. Every time an AI model learns, every time a chatbot answers a question, every time an autonomous system processes enormous amounts of data, there's a good chance NVIDIA is quietly collecting a share of that value. But here's the question almost nobody asks. Why are the richest companies on Earth willingly spending tens of billions of dollars buying NVIDIA chips? Why are governments racing to secure them? And why are some of the world's largest technology firms willing to wait months, sometimes longer, for hardware that disappears almost as soon as it's produced? The obvious answer is demand. The real answer is far more interesting. Because NVIDIA isn't simply manufacturing processors. It's selling access to the infrastructure of the AI revolution. And it has built an economic system where the hardware is only the beginning. Behind every chip lies an ecosystem, a dependency, and a business model that quietly strengthens with every new customer. To understand how NVIDIA became one of the most economically powerful companies on the planet, we first need to go back to a time when its future looked anything but inevitable. In 1993, three engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, started NVIDIA with a simple belief: computing was about to become dramatically more visual. At the time, that sounded ambitious. Personal computers were becoming more common, but few imagined graphics processing would evolve into one of the most valuable technologies on Earth. The company's early years were anything but guaranteed. Competition was fierce. Product cycles were brutal, and one failed launch could have ended the business. Yet NVIDIA survived by focusing on a problem others underestimated: rendering increasingly complex graphics for video games. As gaming evolved, so did the hardware. Traditional CPUs were designed to process tasks one after another, excelling at versatility but struggling with massive parallel workloads. NVIDIA's graphics processing units, or GPUs, took a different approach. But Jensen Huang saw something others didn't. If a GPU could perform millions of mathematical operations at the same time to render images, why couldn't it solve other computational problems just as efficiently? That question led to one of the most important strategic decisions in modern technology. In 2006, NVIDIA introduced CUDA, a software platform that allowed developers to program GPUs for tasks far beyond graphics. To many investors, it looked like an interesting technical feature. To researchers, it quietly unlocked an entirely new class of computing. Universities, scientists, and engineers began experimenting with GPUs to accelerate simulations, medical research, financial modeling, and scientific computing. Then came a discovery that would reshape the entire technology industry. Artificial intelligence, particularly deep learning, required enormous numbers of matrix calculations performed in parallel. Those calculations happened to be exactly what GPUs were built to do. Suddenly, hardware originally designed to make video games look more realistic became the fastest engine for training neural networks. Researchers rushed toward GPUs because they dramatically reduced training times, from months to weeks, and sometimes from weeks to days. Almost overnight, NVIDIA's biggest customers began shifting. Gaming remained important, but a far larger opportunity was emerging inside data centers, where cloud providers and technology companies were preparing for an AI race that most of the world hadn't even noticed. And while everyone else saw faster chips, NVIDIA was quietly building something far more difficult to replicate, a foundation that would eventually make the hardware itself only one piece of a much larger economic machine. At first glance, NVIDIA's business appears surprisingly straightforward. It designs incredibly powerful chips, manufacturers build them, and customers buy them. End of story. Except that isn't the story at all. The chip is merely the ticket of admission. The real product NVIDIA sells is an entire computing ecosystem, and that distinction explains why its position has become so difficult to challenge. Think about electricity. Few businesses choose a power grid because they like the wires. They choose it because everything connected to those wires works together. NVIDIA has created something remarkably similar for artificial intelligence. Every modern AI model is built on an enormous amount of computation. Training a large language model or an advanced image generator requires trillions of mathematical operations running simultaneously. GPUs excel at exactly this kind of parallel processing, making them the preferred engines for AI development. But powerful hardware alone isn't enough. Hardware without software is potential waiting to be unlocked. That realization was behind CUDA. Over nearly 2 decades, CUDA evolved from a programming platform into the operating language of accelerated computing. Thousands of developers learned it. Universities taught it. Research laboratories standardized around it. Software companies optimized for it. Every improvement attracted more developers, and every new developer encouraged more companies to invest in NVIDIA hardware. The result was a powerful network effect. As more AI researchers built tools for CUDA, popular machine learning frameworks became increasingly optimized for NVIDIA GPUs. Libraries, tutorials, research papers, pre-trained models, and enterprise software all began assuming NVIDIA hardware was the default environment. New developers entered the field and naturally learned the same tools, because that was where the ecosystem already existed. This created something economists call increasing returns. Each new participant made the platform more valuable for everyone else, reinforcing NVIDIA's advantage without the company needing to convince every customer individually. Now imagine you're a technology company that has spent 3 years building AI systems on NVIDIA's platform. Your engineers understand CUDA. Your software has been optimized for it. Your internal tools depend on it. Your employees have been trained on it. Millions of lines of code assume that infrastructure exists. Could you switch to another chip supplier? Technically, yes. Economically, that's a very different question. Changing hardware could require rewriting software, retraining engineering teams, validating performance, rebuilding workflows, and accepting months of uncertainty. Even if a competing chip offered similar performance, the total cost of switching could easily outweigh the savings. That's the brilliance of NVIDIA's strategy. It doesn't simply compete on speed. It competes on the cost of leaving. This is why companies often purchase NVIDIA systems rather than just NVIDIA chips. They're buying compatibility, stability, familiar tools, proven workflows, and access to an ecosystem supported by millions of developers worldwide. The hardware generates the performance, but the ecosystem generates the dependence. And that dependence has an extraordinary economic consequence. When customers stop comparing individual products and start investing in an entire platform, price becomes only one part of the decision. That subtle shift helps explain why NVIDIA has been able to achieve something that most hardware manufacturers can only dream of. Pricing power unlike almost anyone else in the semiconductor industry. In most industries, higher prices attract more competition. New suppliers enter the market, production increases, and prices gradually fall. That's how competitive markets are supposed to work. The AI revolution broke that pattern. Almost overnight, every major technology company reached the same conclusion. Whoever builds the most capable AI first could reshape entire industries. Search, cloud computing, software, healthcare, finance, manufacturing, even national defense suddenly depended on one critical resource: compute. And the fastest way to acquire that compute was NVIDIA. The result wasn't ordinary demand. It was a global race. Technology giants began ordering tens of thousands of GPUs at a time. Cloud providers rushed to expand AI infrastructure. Startups backed by billions in venture capital scrambled to secure hardware before competitors did. Governments joined the queue, viewing advanced AI as a matter of economic competitiveness and national security. Demand exploded faster than the industry could manufacture the chips. Even though NVIDIA relies on manufacturing partners, producing cutting-edge AI processors is an extraordinarily complex process. Advanced packaging, high-bandwidth memory, and the world's most sophisticated semiconductor fabrication facilities all became bottlenecks. Building additional capacity wasn't something that could happen in weeks or even months. Scarcity became part of the business model. When customers know supply is limited and waiting could delay an entire AI strategy, price becomes a secondary concern. For a company investing billions of dollars into artificial intelligence, Paying more for GPUs is often far less expensive than falling behind. That's where NVIDIA's pricing power truly emerges. Most hardware companies compete by offering lower prices or thinner profit margins. NVIDIA has largely avoided that trap because customers aren't evaluating the cost of a chip in isolation. They're calculating the value of what that chip enables. If a GPU can reduce AI training time from months to weeks, accelerate product launches, or help capture market share before rivals, its purchase price becomes a small fraction of the opportunity it creates. In economics, urgency changes behavior. When the cost of waiting is greater than the cost of buying, buyers become far less sensitive to price. NVIDIA found itself at the center of exactly that dynamic, allowing it to command premium prices while maintaining gross margins that consistently exceeded those of many traditional semiconductor companies. That combination is exceptionally rare. High demand, limited supply, powerful differentiation, high switching costs, and customers who view the product as mission-critical rather than optional. Together, those forces transformed NVIDIA from a successful chip designer into one of the most profitable technology companies in the world. But extraordinary profits alone don't explain why investors have valued NVIDIA so aggressively. To understand that, we need to look beyond today's earnings and examine the much bigger bet the market is making on the future of artificial intelligence itself. History has a habit of repeating itself, not in exact events, but in economic patterns. During the California gold rush of the mid-1800s, hundreds of thousands of people chased dreams of striking gold. Some became wealthy, most did not. Yet one group consistently made money regardless of who discovered the next fortune: the merchants selling picks, shovels, boots, tents, and supplies. While miners competed against one another, infrastructure providers profited from the competition itself. Every new prospector represented another customer. Success didn't depend on finding gold. It depended on enabling everyone else to search for it. More than 170 years later, the AI economy is following a remarkably similar script. Today's gold isn't buried underground. It's hidden inside data, and the modern pickaxe is an NVIDIA GPU. Every major AI company is racing toward the same objective: build smarter models, launch better products, and capture the next wave of technological value. OpenAI is training increasingly sophisticated language models. Microsoft is embedding AI across its software ecosystem. Google is reinventing search and productivity tools. Meta is investing heavily in open-source AI. Amazon is expanding AI services throughout its cloud platform. From the outside, these companies appear to be competing against one another. From NVIDIA's perspective, they all look like customers. That is an extraordinarily powerful position. Every new AI breakthrough increases demand for more computing. Every larger model requires additional GPUs. Every successful AI application encourages competitors to spend even more, triggering another cycle of investment. Instead of betting on which company will build the best AI assistant, NVIDIA benefits from the entire industry continuing to build. This is why the explosion in capital expenditure across the technology sector matters so much. Over the past few years, the world's largest technology companies have committed hundreds of billions of dollars to expanding AI infrastructure. New data centers are being constructed at an unprecedented pace. Existing facilities are being upgraded with denser racks, faster networking, advanced cooling systems, and enormous clusters of AI accelerators capable of handling workloads that would have seemed unimaginable only a decade ago. At the center of many of those projects sits NVIDIA, not because it owns the data centers, not because it operates the AI services, but because it supplies one of the most essential layers of the entire ecosystem. It's a subtle but incredibly valuable position within the supply chain. NVIDIA doesn't have to predict which chatbot will dominate, which startup will survive, or which enterprise application will become indispensable. As long as organizations continue investing in artificial intelligence, demand for the infrastructure powering that race remains remarkably resilient. But history also teaches another lesson. Every gold rush eventually attracts rivals.